about power functions. What is power function? Power function is x to the power of n. Okay, this n can be positive number, negative number, fractions, whole numbers, can be anything. But we haven't learned how to sketch, except integer, we haven't learned how to sketch the fraction one. So let's have a think about the integer one first. So what's the x to the power of n looks like if n is an odd number? I'll give you an example. What's x cubed looks like? Yeah, that way, that. What's x to the power of 5 looks like? Compared to x to the power of 3, what's the difference? It's more higher, like if for the same x value is higher. But it's not necessarily always true. Is there any intersections between x to the power of 3 and x to the power of 5? Any intersections? There will be 3 points of intersections. What are they? Origin, that's one. What's the other two? 1, 1, and negative 1, negative 1. Okay, they intersect at 3 places. If we sketch for this graph, it can be a really ugly graph, but it needs to look like that. Because it's very tiny, you can't really see that, but like I've enlarged the scale. So if you think that's x to the power of 3, x to the power of 3. Okay, if that's the x to the power of 3, you will intersect at 0, 0, and 1, 1, and negative 1, negative 1 for x to the power of 5. And you know that if it's 2 to the power of 3 and 2 to the power of 5, which one is larger? 2 to the power of 3 and 2 to the power of 5, which is larger? 2 to the power of 5 is larger. So at the point 2, you have a higher graph compared to this blue one. But also you need to meet that point here. So this graph should be like this. Okay, it's actually lower if I make this larger. It is actually lower than the x to the power of 3. Okay, this is x to the power of 5. This is x to the power of 3. Okay, it's actually lower from 0 to 1 and then higher after the point 1. So they have the same shape. Okay, it's all this like kind of S shape. But they need to intersect at the point 1, 1, 0, 0 and negative 1, negative 1. So if you can sketch another one which is x to the power, can't go below. So that's x to the power of 7. Well, my graph is not very right because it looks ugly, but needs to go below the x to the power of 5 and then go higher than x to the power of 5. So that's how this cubic graph looks like. X to the power of n, which n is an odd number. That's how this graph looks like. Well, the green one looks very painful. So it's not looks right, but it should more straight and more smooth. Okay, similar idea for even function. I need to go through this quickly. So for even function, what's x to the power of 2 looks like? X squared. Parabola. What's x to the power of 4 looks like? Okay, what's the intersection between x to the power of 2 and x to the power of 4? Origin, yeah? Same as that one. Similar to that one, I can't say same as that one. X to the power of 4, x to the power of 2, 1, 1. What's the other one? Negative 1, 1. Negative 1, 1. So if you can sketch the x to the power of 2 first. If you can sketch the x to the power of 2 first. Oh, this graph is perfect. Okay, so we have 0, 0. 1, 1 is the intersection, and negative 1, 1 will be the intersection between x to the power of 2 and x to the power of 4. Same idea. The power is larger. After the value 1, you will have like a larger y value as well. Well, you cube it and square it, and you to the power of 4 for that value. So x to the power of 4 should be a higher graph, but it's only when you go after 1 and negative 1. So from here to here, you will go below than this graph, and then go up. Okay, it's below here and going up here. So that's x to the power of 4. So you have 1, 1 and negative 1, 1 as the intersection. But if you have a green one, like you know what's going to happen, like hard to sketch. Okay, green one is to go below than the red one in between negative 1 to 1, and then go above the red graph after that, left hand side and right hand side. So you have 0, 0 as intersection as well. Here, 0, 0. That's how x to the power of 4 looks like for even number, even and odd power. So, okay, the property, you know that I have described it like above the graph, larger power, you have a graph above, smaller, like in between negative 1 to 1, you have a larger power, you have a smaller graph, like lower value. So that's what's going on for the property here. So you can have a look at the property by yourself after class. But what I want to talk about is this. Okay, power functions, which n is a rational number, which means it's a fraction. Fraction power. Well, you can say 3 is a fraction number, 3 over 1, like you know that. Okay, 3 over 1, that's a fraction number. We have different types of fractions. Okay, for the power, we can have odd over even power. So, for example, give me an example. Any odd number over even number? 3 over 4. That's 1, okay? So that's or 3 over 2. That's fine as well. Power like that, x to the power of x3 over 4. Next one is odd over odd. Odd over odd. So I can go, don't tell me 1 over 1, so that's not a good one. So 3 over 5. Okay, 3 over 5. We can go 3 over 1 is one of the odd as well. So even though it's a 3, but it's still an odd number over an odd number. So 3 over 1 is one of the type as well. So even over, yes?
It says in the side thing though, n has to be small.
No, there's more. Let's keep going. Greater than 1 as well. And negative as well. So we have different ones. So we just talk about the possibility first, and then we think about less or greater. So even over odd. So even over odd, I can go 2 over 1. That's even over odd. So that's x to the power of 2. Also, I can have 2 over 3. Okay, that's even over odd as well. Okay, now that becomes the interesting part. Can we have even over even? Why not? Simplify and must go back to one of those. Okay, one of those. So we won't really have 2 or 4, like it's half. So that's odd over even already. So now let's have a think. Can you change this first? Go for n is in between 0 to 1. I forgot the 0. So n is in between 0 to 1. Okay, so let's just look at the first. Okay, look at the first row. Okay, first row. What I want to say is when you sketch the graph, you need to say, okay, which type is this first? And then to say which quadrant my graph could be. Okay, so you need to make sure which quadrant your graph existing first. So how do I think about where my graph should exist? Let's think about the odd over even function. Can you see only exists in the first quadrant? Can you see that? Do you know why only exists in the first quadrant? Let's think about that. if we have x to the power of 3 or 4. Okay, let's think about that. What's that? What's the, if I was to write into the root form, what's the root form? What's the fraction power means? X to the power of what? X to the power of 3 or x to the power of 4? 3. And take a fourth root. Okay, that's the meaning of this question. Let's think about what x is possible to put in. If I put positive x, do I have a positive number out? Yeah, if you put 1, you have 1 out. Can I put negative 1? Can I put negative number? Okay, if you put a negative number after qubit, like, or even any odd power, it's still a negative number. Okay? And then you take an even root. Is that possible? It's not possible. You can't take negative number for even root. So you don't have the negative values. That's why only exists in the first quadrant. You put a positive x in, you get a positive value. That's in the first quadrant for this type of graph. Okay? So it's not going to exist in the second quadrant or the third quadrant because I can't put negative value in. Negative value to an odd power is still a negative value. Negative value take an even root is not possible. So I don't have that part of the domain. So that's why only exists in the first quadrant. So let's think about the quadrant first. So this one is the first quadrant, done. For the second one, odd over odd. So it will be x to the power of odd. Take an odd root. Okay, so it's an odd number here, or 3 or 4. First of all, I put a positive x in. Do I have a positive y? Yes? For example, like that's 3 or 5. X to the power of 3 root 5. Do I have a positive value out? Yes, so it will be in the first quadrant. Okay, part of the graph will be in the first quadrant. Let's think about what will happen if I put a negative value in. I put a negative value into x. After the odd power, I will still have a negative number, right? A negative number take an odd root, what it will be? Negative number take an odd root. Negative number. So you have negative x value, give you negative y value. So that's why this graph will exist in the first and third quadrant. Okay, it will be in the first and third quadrant. It depends on, like, you think about it. I put in a positive x, what I will get out. I put in a negative x. First of all, we need to think about, is that possible to put a negative x in? If it's possible, what y value I will have? So for example, this one, if you put negative 1 in, if you can't see it, try a number. You put negative 1 in. Negative 1 to the power of negative 3, you have negative 1. Negative 1 take a fifth root, you still have negative 1. So negative 1 will give you a negative 1. That's why it must be in the third quadrant and the first quadrant. Okay, so that's odd over odd power. Now think about even over odd power. Well, x to the power of 2 to square root 3. Just take this as example. X to the power of 2 and then take root 3. Okay, you put positive in, you definitely have positive. You always have graph in the first quadrant. Okay, 1 square 1 and cube root 1. Think about what happened you put negative number in. You put negative 1 into the function, you square it, or even power of that negative number. You will have a positive number. A positive number take whatever like root. It still be a positive number. So you will have positive y value. So negative x give you positive y. So that's why it will be in the first and second quadrant, not first and third. Okay, so that's where your graph existed. Any questions for that? Okay, so if you don't have any question with it, you just need to, well, I don't really remember this. What I'm thinking is, like, I was just decide which quadrant it will be in, like when I see the question. I'm not going to remember, oh, odd over even must be in the first. Odd over odd must be in the first and third. Odd and even odd must be in the first and second. It's hard to remember, but by reasoning it, that's why I'm reasoning it for you. Why is first and third? Why is first and second? So trying to do that by yourself when you do the questions. So when you make sure which quadrant your graph will existed, then you will think about the shape of the graph. Okay, all the graph has the same shape. That's the good thing. Okay, so it's either like this or like this or like this, like it's flatter or higher or like more steeper. That's the only difference. But there is a difference by the n value. If your power is a value less than 1, like greater than 0 in between that. So for example, 3 over 4, 3 over 5, 2 over 3, you will have a flatter graph. Okay, it's not increasing very fast. It's like a flatter graph. See that one, like it's all flatter, like this way. If your n is greater than 1, like for example, 3 over 2, 3 over 1, 2 over 1, you will have a graph in a steeper way, like increasing. Can you see the difference? They both increasing graph, but one increase really quick and the other one is like more flat increasing. So that's the only difference. So first of all, you make sure which two quadrant or one quadrant your graph can exist, and second, decide the shape of the graph. Is more flat or more steep? Okay, that's the two things you need to do. Before I start the negative one, let's go to have a look the examples. C and D. Let's have a look at examples C and D. I want to sketch 1 over 5 and 1 over 4. Okay, 1 over 5 and 1 over 4. Can you tell me which quadrant x to the power of 1 over 5 can exist? First and third. First and third. And is that a flatter graph or a more steeper graph? Flat, because it's less than 1. The power is less than 1. So first of all, I put a positive in, I'll get a positive. I put a negative in, I get a negative. So it will be in the first and third quadrant. And then it's a more flatter graph. So the graph, let's say, roughly like that. That's fx. Okay, can you also tell me x to the power of a quarter, which quadrant or quadrants this graph can be? First only or first and second? First only. Okay, first only. Because when you put positive in, you still get positive. When you put negative in, you can't get a negative root. So you only exist in the first one. But what's the shape of the graph? Is there any intersections between x in the first quadrant? Is there any intersections between x to the power of 4, a quarter and 1/5? Origin and 1. Okay, it's always have 1, 1, like as intersection. 1 to the power of any 1 to any power will be 1. Question: do you think after 1? Okay, this point is 1, 1 already. Don't worry about that. Do you think x to the power of quarter will be higher or x to the power of 1/5 will be higher? Okay, this means x to the power of that, and that means this. Quarter is higher. Okay, so 4 numbers times together equals to 5 numbers times together. The 4 number must be a little bit higher to make the same value. Okay, a times a times a times a equals to b times b times b times b times b. Then a must be a little bit larger value because there's more b like given. So after 1, like your x to the power of a quarter needs to be higher, which gives you the same idea as x to the power of 2 and x to the power of 4. It should be lower before. Because I want a higher graph later, it needs to intersect between there. So I can't do that like that. The graph can't go this way. So it must be lower here and then go up here. Can you see that? Intersects here, and then go up. That's Gx. When you sketch your graph, there's more than one graph, you need to label for it. questions? I need to label the intersection 0, 0 and 1, 1. Okay, if you don't have any questions, think about D. Is a power function plus 1. So don't worry about the plus 1. The plus 1 just move the whole graph 1 units up. Let's just think about like x to the power of 2 on 3. Which quadrant or which quadrants this graph will be? Just don't go back. Just trying to think by yourself like what could happen. That can be the same as x to the power of 2 and then take a cube root. It must be in the first already. Can that possible to be in the second or third? It can't be the fourth. First and second. Because you put -1 in, -1 squared give you 1. 1 root still give you 1. So -1, 1 will be the coordinates. That's in the second quadrant, not in the third. So first one always exists. It must be the first and something, or like nothing. So it's the first and second. Is that a flatter graph or like a steep graph? This way or this way? Flatter, like a flower, okay, that way. So also I'll move the point 1 unit up. So 0, 0 becomes 0, 1. Okay, 1 unit up. So you will sketch the graph by this way. Also, it's a symmetrical graph. 0, 1, and it's a flatter graph that way. So that's 0, 1. Well, you can put 1, 2 here and -1, 2 here. It's a fun topic. You need to think which quadrant it needs to be. Actually, I have combined chapter 7 together. Like, it suggests like teach chapter 7 later, but I think it's combined well with the power functions x to the power of n. So I put this here. When we go through chapter 7, we can be more relaxing that time. You can just do practice. That's this one. Okay, I think we get how to sketch power functions with fractions on it. Let's go back to the previous page and think about the negative. Okay, let's think about the negative power. Do you remember what negative power means?
1 over x to the positive.
Yeah, 1 over x to the positive. So for example, we have x to the power of n. What we will have is 1 over x to the power of n. Question is, x to the power of n, if it's an increasing graph, what's 1 over x to the power of n will be? Decreasing. Can you see that? If x to the power of n is increasing graph, and use 1 to divide by the y value, you have a decreasing graph. Because you divide the larger value, there will be a lower y value. Okay, so for example, 1 over 100 and 1 over 1,000. 1 over 1,000 is a lower value. So if it's an increasing graph, that will become a decreasing graph. So now we have the same idea. So in this case, we don't care what is n. Okay, whether it's greater than 1 or less than 1, I don't care. N can be that, or n can be that. I don't care. So it just needs to be a fraction, or even can be integer. For example, 3 over 1, that's 3. So 1 over x to the power of 3, what that looks like. So again, we don't need to think about the negative. What we need to think about is n, the value n. Is that odd over odd, odd or even over odd? We still think about that. We still make sure which quadrant your graph will be. Okay, still make sure which quadrant your graph will be. So still think about the quadrant. And then you will always have xy intercept in asymptotes here and here. Okay, there's asymptotes. Always have asymptotes. Well, if there's transformation happening, like your asymptotes will be transferred as well. But like just for purely x to the power of -n, you will always have asymptotes at y equals to 0 and x equals to 0. So you put asymptotes on your graph. I can't put on mine because I've just screenshot for that graph. So asymptotes there, asymptotes there. Make sure the quadrant and all the graph looks the same. Okay, it doesn't matter what's the n value. So it's all like decreasing graph like that way. Okay, so you don't like which quadrant. Can you see it's matching exactly the same quadrant, same quadrant, same quadrant, and whatever your graph looks like before. like it's all increasing graph, so it's all become decreasing graph in the first quadrant. So the first quadrant always looks like that. And then you have like truncus, hyperbola shape. Okay, only truncus or hyperbola shape. So that's x to the power of, well, you can see that's x to the power of -1. Yeah, that's x to the power of -1. Well, -1 is 1 over 1. So old over old, old over old, you have that graph. What's truncus? Truncus is x to the power of -2. 2 over 1, old over, even over old. Okay, so that's the truncus graph, 1 over x squared. So it will be this shape. So still make sure which quadrant is that, put the asymptotes on, and then draw the rectangular hyperbola shape or truncus shape, or only one side. Then let's have a look about x plus 1 to the power of -5 over 4. Okay, so let's think about x to the power of -5 over 6, 5 over 6, not 4. 5 over 6 first. What's the plus 1 will make the graph looks like? Like what's happening if you plus the 1 there? Move to the left by 1 unit. Okay, if you can just think about what that graph looks like. Okay, we sketch x to the power of -5 over 6. Which quadrant your graph will be? First? And? Is there an and? Just first. Because x to the power of 5 and then take a 6th root, it's still -1 still become -1. You take a root, you can't take a negative root for -1. So you only have the first quadrant. So if it's in the first quadrant and also it's a negative, we will have asymptotes here. And then the graph looks like this. Okay, that's for x to the power of -5 over 6. So you move this thing to the left by 1 unit. Okay, you move it to the left by 1 unit. So the y asymptote's not going to change unless you move up or down. So y equals to 0, label that. You move to the left by 1 unit, so the x asymptotes will move to the left like this. X to the power of -1. And you graph like this between the two asymptotes. What's the intersection? Y-intercepts, not intersection. 0, 1. Because if you set x equals to 0, we have 1. 1 to any power will still be 1. So 0, 1 will be the y-intercept. So that's how the graph looks like. Wait, there shouldn't be a C here. Do you have C on your booklet? Yeah, just get rid of the C. There's no C here. Okay, x to the power of -3. Okay, -3. We can treat -3 as x to the power of -3 over 1. And -1 is x to the power of -1 over 1. Alright, so they are the same. They are all old over old, old over old. So which quadrants it will be? First and third. Let's sketch x to the power of -1 first. That's just the rectangular hyperbola. So we sketch that one as the base one first. Okay, asymptotes. Don't forget your asymptotes. Y equals to 0 and x equals to 0. Even though your asymptotes is on the xy axis, you still need to label them. Okay, you still need to sketch them out and label them. So that's the asymptotes. Let's sketch 1 over x. Well, this is 1 over x and this is 1 over x to the power of 3. I'll use the blue one to sketch 1 over x. That's 1 over x. Is there any intersections between those two graphs? 1? Because 1 to the power of any power will still be 1. So you have intersections at 1, 1. Just make it longer. Okay, you have 1, 1. And that side you have 1, 1. Negative 1 and negative 1. Okay. There's 2 options given to you. Just think about the positive one. I'm going to sketch 1 over x cubed. Should my graph looks like this? Too bad. My graph looks like this. Can you see like red on the top and then bottom? Or should that be another way? The other way, like this. Can you see the difference? Because they only intersect once. It must go cross. It's either this way or the other way. Which way it should be? The new graph after 1, let's just say after 1, should that graph be below or above? Like this way. Should the graph go here or here? Up or down? Well, if you can't see it, try a value. Try 2. Let's try 2. That's a half. Okay? That's 1 on 8. Which one is larger? Half is larger. So 1/8 will be below. And 2 blue graph should be above the red graph. So the way we should sketch for it. It's always touching. Okay, it's not touching now. You can't touch and it needs to be parallel. So it needs to go below. That's x to the power of 1 over x to the power of 3, and the other one is 1 over x. How should I sketch that one? This way or the other way? Well, remember it needs to be symmetrical. That way? That way? Sure? Okay, it's that way, okay? Red one near the... Because on the positive side, the red one more closer to the x-axis. Then on the negative side, you should go closer than the x-axis as well. So you should be this way. Okay, the red one is 1 over x to the power of 3 and the blue one is 1 over x. Well, actually, my graph is not really accurate because, well, it's not accurate for sure, but like it's wrong. The asymptotes needs to go longer and your graph needs to get closer to the asymptotes and it needs to be parallel to the asymptotes. But I know that this graph is hard to sketch. Just want to let you to know. When you sketch asymptotes, the asymptotes must be longer than the graph, and the graph needs to get close enough to the asymptotes and parallel to the asymptotes. Okay, that's how you should sketch a graph with asymptotes. Okay, that's a correct graph. Well, I should just extend that a little bit longer. And the blue one is fine. The red one, well, I have no choice for the red one. That's it for the power functions. Do you have any question? I have go through all the examples with you today. So it's more like chapter 7 knowledge. So you can have a look chapter 7 for like practice if you have time. But if you don't have time, you can wait to chapter 7 and then practice on that. Before you start talking, what I want you to do is tonight, okay, because I want to go through the examples tomorrow. So I want you to go from page 33 to page 36. So those pages is two questions. Okay, it's a long exam question. It's a practice question. I really like that one. I'm not sure if I can finish one question in one lesson, but I need you to try first and then I go through. I can't let you to read and then do and then I go explain. I don't have enough time. So finish this question tonight. It's not necessary you can do everything. Okay, just finish the booklet, try them. At least you understand what the question is talking about, and it's easier for me to talk about it tomorrow.